Hi there. I'm making this video to help you with evolving trees of phylogenetic activity. So the activity looks like this. There's a little background information, and then part 1 involves interpreting a phylogenetic tree that's given to you. So this is a tree of a bunch of different animals, different phyla of animals, and how they are related to each other based on properties that they all have, or some of them have. And your first part of this exercise involves looking at the tree and filling in this table on the second page with which phyla have that property. So the first property in the table is notochord, and you'll notice that chordata branches off of the tree after the notochord trait, meaning that chordata have a notochord. So I put a little plus in here, okay? The next property is pharyngeal slits. So I notice that pharyngeal slits on the cladogram is right here, and hemichordata and chordata branch off after pharyngeal slits, meaning both of them have it. So I'd put plus marks in the table here and here for pharyngeal slits for hemichordata and chordata. Revisit this a little bit because you'll notice that after, for example, bilateral symmetry, sure, hemichordata, chordata, and echinodermata have bilateral symmetry, but so do all of these. They branch off after bilateral symmetry. So Platyhelminthes and Mollusca and Annelida and Arthropoda also have bilateral symmetry. So some of these traits are going to have a lot of plus marks in the table, and some of them are only going to have 1 or 2. Right? So look at that carefully. Make sure you fill that out. The first question involves then, when you have this table correctly filled out, comparing the table, the pattern of plus marks in the table, to the branches on the phylogenetic tree. How are they similar? Do they look alike? Do they look like they're related? That's what that first question deals with. So once you've got the table done and you've answered that first question, return to the video. But until then, pause the video. Okay, you're back. So the next part of this activity talks about a group of hypothetical fly species and forming a cladogram or a phylogenetic tree that shows how those fly species are related. That's the next part of this, part 2. So the hypothetical fly species looks like this. It's the last page of the activity, and you have 5 fly species. You'll notice that they all have 6 legs and they all have wings, but then there are some other subtle differences in them. Your job is to kind of predict how they're related, and then look at each property one at a time, and then build a cladogram or a phylogenetic tree one property at a time based on what you see in their image. Okay, so how do we do that? Well, I'm going to do a phylogenetic analysis of some different creatures to kind of show you how it goes. Okay, so here I have 5 different creatures. Okay, they're all kind of related in that, well, there's some similarities in their appearance, but then there's also some differences. And I'm going to use those differences and similarities to show how they descended from a common ancestor. Because that's how evolution works. There's some common ancestor that undergoes some mutation somewhere along the line, and that mutation may or may not lead to an advantage. The ones that lead to an advantage tend to survive, and so then they reproduce and they form more that have the same kind of characteristics, and that's how evolution works. So which one of these seems to be the common ancestor? Sometimes it's easier to look at which one of these seems to be the most modern looking and which one seems to be the most primitive looking. Well, this one looks like it's got a wing here maybe, and a nose maybe, I don't know. And this one is kind of more nondescript. It does have legs and feet and arms and hands, but maybe not as sophisticated as the first one. This one's very sophisticated. It's got tail spikes and a back fin and antennae. So that one's a really modern one. This one's kind of maybe in between because, look, it's got arm fins instead of arms with hands and leg fins instead of legs with feet. And then this one also looks rather modern because it's got a beak and wings, kind of more defined, looks more bird-like maybe than all the other ones. Well, so the most primitive looking one seems to be this one, doesn't it? So we'll put this at the bottom. That would be the common ancestor. And along the way, we notice that some of these have wings and some of them don't. So the ones that have wings are probably related to each other, right? Okay, So we're going to draw a branch off of this common ancestor that goes to these two. Don't worry, I'm going to kind of sort them and differentiate between them shortly. And then we're going to draw another branch off of this common ancestor that leads to the other ones. Okay, so, whoops. Now I kind of have them divvied up into two groups, and I can look at the two groups separately. Okay, now looking at the two groups, it looks like this one has a back fin and a tail fin with spikes and so on, and it's a little more modern looking than this one. So these obviously branched off somewhere at some other time, like not at the same time, because they have their different characteristics. So this one branches off here, and this one maybe branches off here. Okay, and I'm building a tree, right? What characteristic do I put on this branch for this one with the antennae and stuff? Well, it could be any of those characteristics, really, couldn't it? I think maybe I could put back fin, which is a dorsal fin, all right? And that would kind of sum up why that one is different from that one and also different from its ancestor. This one has a tail fin. It has a tail fin. We call that a caudal fin. So let's put that as a characteristic on this branch. Caudal fin. Caudal fin. Okay. So that it's differentiated from this one, but it came from that common ancestor and evolved a caudal fin. Okay, last two. All right, this one seems to have a nose. Okay. Or maybe it's the beginnings of a beak, right? And this one has a beak. Okay. So maybe these are related to each other really closely. So maybe they don't really branch off of each other. Sometimes that happens too. This one, after evolving more of a beak, ended up evolving into this one, yes? And they came from that common ancestor, but what do they have in common? What characteristic separates them from their ancestor? Well, that would be that they have wings for arms. So we'll put have wings on this one, right? And that way we know how those are different from the other ones. So what I've set up is basically a phylogenetic tree of these organisms. Their common ancestor is identified, where they branched off and why, what characteristic they have that the other ones don't have. And that's what I'm trying to do. Going back to evolving trees, you're trying to do that with the fly species. So your first thing is a prediction. It's a prediction. You're going to look at these fly species and you're going to predict what's related to what, okay? Maybe you're going to predict that one of them was the common ancestor, or maybe you're going to predict that they came from a common ancestor and then all five differentiated or branched off somewhere. But that first one is just a prediction. So you predict it, and once you've predicted it, draw your prediction in as a cladogram, as a phylogenetic tree with branches. Where did A branch off? Where did the E branch off? And so on. That's just a prediction. It's okay if it's wrong, right? No big deal. It's a prediction. Then you're going to test your hypothesis, because that prediction is your hypothesis, by comparing the traits of each of these five species of insect. Which ones have large wings? Well, looking at the diagram, it looks like a lot of them have large wings, don't they? Only E has small wings, so I would put plus marks in A, B, C, and D because they have large wings. And we'll put plus marks in for which ones have stinger and so on. So fill out this table like you did the first one, except instead of basing it on the phylogenetic tree, you're basing it on the actual traits of the organisms from the last page of the exercise, okay? And then once you've built that table, then we're going to build a phylogenetic tree. It's like we're doing this, what we did first, backwards. We're going to build this kind of cladogram or phylogenetic tree from a table of traits. Okay, so when you get that far, if you get stuck or you have questions, contact me and we'll work through it. Okay, good luck.